let us first confirm whether these two terms are perfect square, starting with the numerical coefficient 25. Now, moving on to the literal coefficients. A literal coefficient is a perfect square if, so what's left are 49, b to the 12th, e to the 10th, and then r to the 6th. So that's how we isolate common factors between two or more terms. Having fractions as numerical coefficients, that is challenge enough. So if you have a problem whose numerical coefficients are fractions with common factors, then your teacher must really hate you. Okay, so just kidding. Your teacher loves you. Okay, so again, having fractions. Hi there, Jordan here from Digital Owl. In this video, I will show you my workflow in finding the factors of a difference of two squares. Let's begin. The difference of two squares is an ingenious way of finding the factors of mathematical expressions. Expressing these illustrations as factors are significant in manipulating and solving more complex arithmetical problems. Alright, so let's dive right in onto our first example. We have 25 a to the 6th minus b to the 4th c to the 8th. So this is a difference, expressed as a difference. As you can see, we have a subtraction here, and we have two terms. So let us first confirm whether these two terms are perfect square, starting with the numerical coefficient 25. 25 is a perfect square as shown in our table here. If a number is 1, its square root is 1 because 1 times 1 is equal to 1. Now, if a number is 25, then its square root is 5 because 5 times 5 is 25. So 25 is a perfect square. Now, moving on to the literal coefficients. A literal coefficient is a perfect square if its exponent is a positive even integer. So the exponent here is 6, and 6 is a positive even integer. Therefore, 25a raised to 6 is a perfect square. Now, to the next term, we have b to the 4th, c to the 8th. As you can see, both literal coefficients have positive even integers as exponents. 4 and 8 are both positive even integers. So, we have here a difference of two squares. So, let's now proceed to determining the factors. So, the first step is to get the square root of the first term. So, the first term is 25a raised to 6. So, the square root of 25 is 5. And for the literal coefficient, the square root of it is we simply cut the exponent by half. So therefore, the square root of a raised to 6 is a cube. So that is the square root of the first term. Then we move on to getting the square root of the second term. The second term is b to the 4th, c to the 8th. Then the square root of this expression is we simply cut the exponent by half. So the square root of b to the 4th is b squared, and the square root of c to the 8th is c to the 4th. The next step will be we will get the two terms expressed as a sum multiplied to the same terms expressed as a difference. So we simply get 5a cubed plus b squared c to the 4th. That is our first binomial multiplied by the same terms, this time expressed as a difference, 5a cubed minus b squared c to the 4th. So these are the factors of the given expression 25a to the 6th minus b to the 4th c to the 8th. Now, if you are interested in automating these kinds of problems, I have created a course entitled The Difference of Two Squares factor finder, or I'd like to call it the DOTS F2. There you will learn how to manipulate a software that I created that can instantly display the factors of a given expression, of course, pertaining to the difference of two squares. Hey guys, before we continue, it would be nice if you'd give us a like, subscribe on this channel, and hit that notification bell for you to be prompted about future videos. Okay, so continuing the journey, let's have the second example. We have 45c to the 8 d cubed m to the 16th minus 245d to the 15th e to the 10th r to the 6th. Now, following the first step from our first example, we determine or confirm if these two terms are perfect squares. However, we all know that 45 and 245 are not perfect squares, and we have a literal coefficient here in which the exponent is not a positive even integer. So therefore, these two terms are not perfect squares. So sometimes we have to get back to basics. So it is important that you really know the basics. Particularly, we are in factors or factoring. So we have to determine, or we have to find out the greatest common factor between these two terms. And we can notice that 45, the factors are 9 multiplied by 5, and 245 is 49 times 5. And then we have here, since both terms have a literal coefficient d, the common factor between these two d is the d cubed. So d cubed is a common factor, and then d to the 15th, we can split that into d cubed and then d 12th to the 12th. So therefore, we have a common factor and we must isolate that like this. So 5d cubed, and then from 45c to the 8 d cubed m to the 16th, the factors left are 9c to the 8 m to the 16th minus, okay, so from 245, so we isolated 5d cubed, so what's left are 49 d to the 12th, e to the 10th, and then r to the 6th. So that's how we isolate common factors between one or between the two or more terms. Then let's proceed to getting the square root of the first term. So the first term this time is the 9c to the 8m to the 16th. So it is now a perfect square. The square root of 9 is 3. C to the 8 is c to the 4th. We simply reduce the exponent by half. M to the 16th, the square root is m to the 8th. Then proceeding to getting the square root of the second term, 49, the square root is 7. D to the 12th, the square root is d to the 6th. E to the 10th, e to the 5th. R to the 6th, square root is r cubed. Okay, we simply cut the exponent by half. And finally, we express our factors. So the common factors, so since we have a common factor here, include that in the final answer. So 5d cubed multiplied by the two terms, 3c to the 4th m to the 8th, expressed as a sum, plus 7d to the 6th e to the 5th r cubed. And then multiplied to these two terms again, this time expressed as a difference. 3c to the 4th m to the 8th minus 7d to the 6th e to the 5th r cubed. Now, the difference of two squares, factor finder is not limited to integer coefficients only. It may also be used for problems with fractions or fractional numerical coefficients, just like the example shown on our next problem. Alright, so let's have our third problem. The 81 over 121 b to the 12h squared minus 100 over 169 m to the 8th 18th u to the 4th z to the 14th. So as promised, we have a difference of two squares in which the numerical coefficients are fractions. So it's fairly easy. So we simply follow the procedures that we have made earlier. Now, having fractions as numerical coefficients, that is challenge enough. So, if you have a problem whose numerical coefficients are fractions with common factors, then your teacher must really hate you. Okay, so just kidding. Your teacher loves you. Okay, so again, having fractions as numerical coefficients are challenge enough. So it is extremely unlikely that you will have a fraction numerical coefficients in which you have to factor out common factors between these two squares. So that is highly unlikely. Moving on. So the first step is to square or get the square root of the first term. So what we do on the numerator is we also do that to the denominator. So the square root of 81 is 9. Square root of 121 is 11. Square root of b to the 12th is b to the 6th. We simply cut the exponent by half. And h squared, the square root is h raised to 1, or as a general rule in mathematics, if the exponent is 1, then there is no need to write it. Okay? And then for the next step, we also get the square root of the second term. So the square root of 100 is 10, as shown here. The square root of 100 is 10. Square root of 169 is 13. And then m to the 18th is m to the 9th. Square root of u to the 4th is u squared. And z to the 14th is z to the 7th. And finally, we get or we express the two terms. Okay, we express this as a sum multiplied to the same terms expressed as a difference. So 9 over 11 b to the 6h plus 10 over 13 m to the 9th u squared z to the 7th multiplied by, again, these two terms, this time expressed as a subtraction, so or as a difference. So 9 over 11 b to the 6h minus 10 over 13 m to the 9th u squared z to the 7th. So that is our third problem. Now, the difference of two squares factor finder also has a feature called the lowest term verifier. This is extremely useful to ensure that the fractions that are being solved are already in its lowest term, and identify the lowest term of that fraction if not. Now, this is the conclusion of my video regarding my strategy in finding the factors of a difference of two squares. I pray that you were able to grasp this simple mathematical style that I use. I trust that we can see each other again on my next video. It's goodbye for now.